Ever wonder what a rover on Mars and your braces have in common? It sounds like the start of a weird joke, but the answer is a mind-blowing material called Nitinol. This isn't just any metal, it's a memory metal, and it's revolutionizing how we explore other planets. Today, we're diving deep into the science behind NASA's incredible shape memory alloy wheels. Let's rewind a bit. Exploring Mars is tough. The terrain is brutal, rocky, sandy, and unforgiving. Just look at the Curiosity rover. Its aluminum wheels, after years of service, started showing serious signs of wear and tear, dents, punctures, and cracks. Aluminum is light and strong, but on Mars, it has its limits. Every dent is a potential point of failure, and you can't exactly call roadside assistance millions of miles from home. NASA's engineers knew they needed a better solution for future, heavier missions. They needed a wheel that was not only tough, but could also handle damage in a completely new way. Enter Nitinol. The name itself is a clue to its origin: nickel, titanium, and the Naval Ordnance Laboratory where it was discovered back in the 1960s. Nitinol is a type of shape memory alloy, or SMA. So, what does that mean? Imagine you have a paperclip made of this stuff. You can bend it, twist it, and completely deform it into a tangled mess. But then, with just a little bit of heat, say, from a hairdryer or warm water, it magically springs back to its original paperclip shape. It remembers its form. This incredible property comes from its unique atomic structure. At cooler temperatures, Nitinol is in a phase called martensite. In this state, the crystal lattice is flexible and can be easily deformed. Think of it like a deck of cards you can easily slide and rearrange. But when you heat it up, it transforms into a phase called austenite. The austenite phase has a very specific, rigid, and predetermined crystal structure. As the metal transitions, it forces itself back into that original, remembered shape with considerable force. It's a physical transformation happening at the atomic level. But here's where it gets even cooler for NASA. The specific blend of nickel and titanium used in their rover wheels has a special property called superelasticity. This means it can do its shape-changing trick without needing heat. At room temperature, or, more importantly, at Martian temperatures, the metal can undergo massive deformation, up to 30 times more than ordinary steel, and still spring right back to its original shape once the force is removed. You can squish it, and it just bounces back, no heat required. This is the game changer. So, how do you turn this amazing metal into a wheel? You can't just cast it like you would with aluminum. Instead, NASA, in collaboration with Goodyear, developed a new kind of tire made from a mesh of woven Nitinol wires. It looks a bit like futuristic chainmail. This design has several huge advantages. First, it's compliant. When this wheel rolls over a sharp Martian rock, it doesn't try to fight it, it envelops it. The mesh deforms around the obstacle, spreading the load across a larger surface area. This dramatically improves traction, allowing the rover to climb sandy slopes and navigate rocky fields more effectively than a rigid wheel ever could. Imagine driving on sand with a flat tire versus a properly inflated one. The flat one actually gets better grip because it spreads its weight. The Nitinol mesh tire acts like that, but without ever going flat. Second, it's insanely durable. Remember those dents and punctures on Curiosity's wheels? With a Nitinol mesh tire, that's not really a problem. If a rock deforms a section of the wheel, the superelastic properties of the alloy mean it will just spring back into shape after it rolls past. The tire essentially heals itself from dents. It can withstand deformation that would completely destroy an aluminum wheel and just keep on rolling. This means longer-lasting missions and the ability to send heavier rovers with more scientific instruments to explore even more challenging terrain. The development process was fascinating. Engineers at NASA's Glenn Research Center put these tires through absolute torture. They rolled them over mock Martian landscapes filled with sharp, jagged rocks, ran them on punishing test beds for hundreds of kilometers, and subjected them to the extreme temperature swings they would experience on Mars, which can go from balmy highs to freezing lows in a single day. Through all this, the Nitinol wheels demonstrated superior performance, showing minimal damage compared to their rigid-wheeled counterparts. The implications are huge. These spring tires aren't just for Mars. NASA is looking at using them for lunar missions as well, where the fine, abrasive moon dust poses its own set of challenges. And the technology is even finding its way back to Earth. Imagine airless, puncture-proof tires for vehicles in mining, agriculture, or the military, operating in the harshest environments on our own planet. The technology originally developed for space exploration could soon be making life here on Earth safer and more efficient. From medical stents that open up arteries inside the human body to rover wheels exploring distant worlds, shape memory alloys like Nitinol are a perfect example of how advanced materials science can solve some of engineering's toughest problems. It is a story of looking at a problem like a dented wheel on Mars, and not just trying to make the old solution stronger, but completely rethinking the solution from the atoms up. It's a testament to human ingenuity. So next time you see those incredible images beamed back from a Mars rover, take a closer look at its wheels. You're not just looking at tires, you're looking at a marvel of material science, a metal with a memory that is carrying our dreams of exploration across the surface of another world. The journey to the stars is paved with innovation, and sometimes that innovation looks a lot like a set of self-healing, chainmail tires. Thanks for joining me on this deep dive into NASA's amazing memory metal. If you enjoyed this journey into space-age engineering, make sure to hit that like button and subscribe for more stories from the cutting edge of science and technology. See you in the next one.